Okay, so let's take a look at a Riemann sum in application. Again, these are more like types of situations you're going to see yourself in the AP exam, as well as your test for this class as well too. So we've got a chart. It shows the growth of a plant over time. T is measured in years, and the rate of change of the height of the plant, R of T, is measured in feet per year. Now here's where you're going to starting to get confused, or you've got to make sure you really pay attention to the wording of the problem. Because of the fact that it tells you have a rate of change, and you also know you have a unit of feet per year, then that's indicating that R of T is a derivative. So this is a derivative. And everything we're going to be working with in this particular rest of the course is going to be knowing that we have derivatives and going back to those original functions and such. So we're going to apply integration through this idea of Riemann sums. We're going to try to find out how much this plant has grown based on the fact that we know the rate at which it has been growing. So we're going to do 3 Riemann sums. We're going to do a left, a right, and a trapezoidal to help us answer the question of essentially how much did this plant grow? So again, notice in this table why they like to use tables in the AP exam is because of the fact that if you look, we're not going to have equal intervals. So between years 2 and 4, that's 2. So if we're doing a Riemann sum and we're doing a left or a right, we're using rectangles. And the width of our rectangle is not going to be the same. With between 4 and 5, year 4 and 5 has only 1 year difference. Between 5 and 8, there's 3 years difference. Between 8 and 9, there's 1 year. Between 9 and 11, there's a 2-year gap. So these particular Riemann sums, you will not have the same width for all of your rectangles. So that's kind of important to know. Now, I'm still going to draw out my left, right, and such. Oh, yes, you do need to know that you are using 5 sub-intervals, is what you will be told. They usually won't say sub 5 rectangles because of the fact if we're doing trapezoids, we're not using rectangles. So I know I'm going to break this up into 5 sub-intervals. Here's my 1, 2, 3, 4, 5. Same thing I always still write down. My first interval goes from 2 to 4. My next interval goes from 4 to 5, 5 to 8, 8 to 9, and 9 to 11. 1, 2, 3, 4, 5. So either 5 rectangles, 5 trapezoids. But again, notice the difference between each interval. The interval widths are not the same. So our delta x is different for each one. So again, here we are 2, 1, 3, 1, and 2. All right, so we're going to approximate. So we're going to take, well, it's true. I guess this is really not delta x in this particular case. It's really delta t since we are dealing in terms of t. So we want to find the rectangle. We're going to use the left endpoints here to approximate. So I'm going to use the 2, 4, 5, 8, and 9. So I have my delta t times my r of t, because that's the value that I happen to know. So my delta t is 2. Now notice again, that's going to be a difference of 2 years. My r of t, which is my value of r of 2, happens to be 3, but it's 3 feet per year. Now let's make sure we remember what we know about units. Years cross out, and that's going to let you with an answer of 6 feet. So we're going to do that for each one of those endpoints. So again, that was delta t. This was looking at essentially r of 2. So now we're going to find our change in our next interval. That was 1 times this time r of 4. So that gets me 1 times 1, 1 foot. Next interval, that's got a width of 3. Now I want R of 5. So that gets me 3 times 7. That's 21 feet. Plus, so 1, 2, 3, our next one, width of 1 times R of 8. R of 8 was 4 feet. And our last one, width of 2, and you're looking for R of 9. That was 1, plus 2 more feet. So that gets me 10, 31, 32, 33, 34. An accumulation. An accumulation in this time of our actual growth. So we know the rate at which we were growing, so it actually tells us our overall growth. Between year 2 and year 11, we can say that this plant grew a total of 34 feet. So our right endpoint approximation, which by the way, if we look at the function, we can see the y values are increasing. So therefore, this left endpoint approximation has to be an underestimate. Our right endpoint should be an overestimate of this. Let's see if our numbers tell us that. So now we're going to use the right endpoints of each one of these intervals. But notice the width is still going to be the same. So I'm going to have 2 times r of 4, 1 times r of 5, 3 times r of 8, 1 times r of 9, and 2 times r of 11, which that's going to get me 2 times 1, 1 times 7, 3 times 4, 1 times 1, 2 times 12. And these are most likely non-calculator problems as well. And put that all together, 7, 8, 9, 10, 46 feet, which is our overestimate. So we know our actual area lies somewhere in between. Trapezoidal estimate is going to give us something that's a little bit closer. So let's remember now the trapezoidal estimate, we could actually use trapezoids if we wanted to. If you want to do the trapezoid the long way, just to see it. So the area of a trapezoid is 1/2 that height, which would be this, times the sum of, and this would be R2 plus R4. And that's just going to find you the area of that first trapezoid. Then we repeat the process. 1/2 is just a constant. So now this would be R4 plus R5. Plus, we come down here. Next one would be 1/2 times 3. R5 plus R8. Plus 1/2 times 1. R8 plus R9. And finally, 1/2 times 2. R9 plus R11. Now you can do that whole calculation, but that is going to get you the same answer as your left endpoint plus your right endpoint approximations divided by 2, which is going to be 34 plus 46. Divide that by 2. My trapezoidal approximation, sorry if I'm off the screen there, shows you get an approximation of 40 feet. So again, all this is just, again, because there's some Khan Academy problems I definitely want you to do that deal with word problems. When you have yourself a table, always double check the intervals. Chances are the intervals are not going to be of equal width. It's always best interest to write out all of your intervals, depending on how many they want you to do, be it 3, be it 2, what have you. Calculate your widths for each one, and therefore you don't mess them up. Right endpoint, left endpoint are the same thing. A little bit of difference on this one is, again, understanding what your units are. Units are ridiculously important when we get into word problems, and they should definitely not be ignored.